Hi, this is Chris Phillips, and I'm going to be going over how I built my parabolic mirror using like hardware store parts. The parabola is a pretty basic shape. The hardest part is actually getting that curve and keeping that curve. I used a couple different things. You can get them all from your usual hardware store. Got some wood. Used wood to build a frame. Used a 3x3 piece of PVC board with a hole in the center and a bike pump valve and a Mylar blanket. And I drilled a hole in the PVC board, put the cutout bike pump hole in the very center, and used that as a one-way valve. I used a lot of super glue to hold it in place and let that dry. And then it was stuck in there pretty hard. And then I set that on my wooden frame. So once I had it on there, I took the Maritime epoxy and made a circle around the center of the board. I used a string to measure it out. Put the Maritime epoxy on there after I mixed it, and then I took the Mylar blanket and gently put it on the epoxy on top of the board. Made sure I didn't get any in the center hole where the bike pump valve is, and I let it dry for about 30 minutes. After about 30 minutes, I gently pumped it up, which is what you see here, so it had a little bit of an arch to it, and I let it sit for 5 hours. I made sure that it wasn't leaking, and it was slowly stretching out and getting that nice parabolic shape. Like I said, it took about 5 hours to dry, and you want to be looking for there's no holes or it's not leaking anywhere. And then after that, I started prepping to lay the fiberglass. After I laid the fiberglass, it took another maybe 5 hours to dry. You gotta mix the resin with the hardener, and I poured that over the top of the blown out Mylar blanket and laid 5 separate pieces of fiberglass, and I put resin in between each piece, and I let it dry for about 5 hours. All while I was doing this, I would have to stop and pump the Mylar blanket up because somehow a hole got popped in it and it kept leaking out air. It did stay. It did eventually like adhere to the Mylar and the shape. It all worked out, but that was definitely an issue. So here are the dimensions of the parabolic mirror. Obviously the vertex is going to be at 0, 0. So I just use the standard form dropped in 0, 0, and you get the stripped down version of that equation, which is x squared equals 4py. So I measured the diameter in centimeters. It came out to 68.5 centimeters across. Cut that in half, your radius is 34.25. And the depth is 8.1 centimeters. Measuring the depth was kind of difficult, but I used a wood square. So I measured out the depth, and I assigned those points to the different points in the on the parabola. And as you see that, you can just pick a point. I picked the right point, the 34.25, 8.1, and just dropped it into the equation to get P. So by getting P, it kind of solved a lot of the questions I had with this and helps me rewrite the equation. And for P, that makes sense. It makes sense that it was 0 and then 36.21, and 36.21 centimeters from the vertex is about right. It's about 14 inches, and so that's right about where I had the best heating for it. Now, as time went on, the mirror started to deteriorate and lose shape a little bit, but it did the job, and that was definitely about the right distance for where the focus should be. So the only thing I had available to use to measure the temperature was a kid's oral thermometer, and so that's what I used. I did some testing with it, and it topped out at around 115, 116. It would just give an error message and say hi, hi, hi. So I think it's just a safety thing. But I was able to measure the temperature over 20 minutes. It was pretty cloudy all this week, so I had a really hard time getting good sunlight. But I did measure the temperature here. X is in minutes, Y is in degrees Fahrenheit, and you can see that here in this graph. Just made a little linear model of it. I got a hold of a old satellite dish for TV, and I used that to make another one. I just cut the Mylar into strips and used spray adhesive and sprayed it onto the satellite dish, and that actually heated up the water a lot better. I have the math after the short little video I'm going to show here about it, explaining where its foci is and its diameter and all that vertices. And but due to time, I'm going to wrap it up, and thanks. And I'm hoping that the screws have been absorbing heat. Ooh, wow, that is very warm. Okay. Really like I turned it. These screws are getting more heat. Wow, that is very hot. It's like a warm hot cup of coffee or tea. And this parabolic TV dish mirror definitely got the water a lot hotter. I mean, I don't know if it wasn't boiling, but it was steaming off by the end of it. By the end of the hour I had it in the sun, and that was definitely a lot more than the homemade mirror. So for the sake of time, I'm not going to get into the TV satellite dish parabolic mirror, but it worked pretty well. It heated up the water a lot more. It didn't boil, but it got pretty hot. When I did this one, I didn't have a thermometer with me. But I'm going to have the math for it after this, and you can look at it. But definitely the shape, getting that perfect shape so that you get all those, as you would say, beams of sunshine in the right direction is critical. And then also having a flat surface, a lot harder to get than I thought. Adding something black, such as steel wool or black screws, into the water definitely accelerates the heating because it allows for absorption. Also having the crystal glass like in that cup right there, that also diffracts light, which slows it down. So it's been my parabolic mirror project. This is Chris Phillips. Thanks.